In the next module of this particular chapter, we will understand what is total internal reflection and we'll understand the phenomena of mirage. Now firstly, looking at this wonderful phenomena, total internal reflection. For this, let us take this tank containing water. Now as you can see, in the bottom left corner, there's a torch. Now when I switch on the torch, the light from the torch will go upwards. Now this light which is going upwards will hit the interface at different angles, and so therefore at each and every point we make a normal to understand what happens to light. Now in the first case, when light is coming out, this light is going straight. As it is going straight, there will not be any refraction and the light will come out straight. Now let's go to the second ray. This light ray is going and hitting the interface, let us say at 30 degree. So there will be refraction, and we know that as light is traveling from a denser to rarer medium, it will bend away from the normal. So let us say angle of incidence is 30 degree, then angle of refraction will be 50 degree. I increase the angle of incidence. So now angle of incidence has increased to 35. You can see there is a big shift in the angle of refraction and it has become 70. The next ray of light hits the interface at 40 degree and you can see that angle of refraction has become 90 degree. Now students, when angle of refraction is 90 degree, that is called as critical angle. So students, what is critical angle? Critical angle is angle of incidence for which the angle of refraction is 90 degree. Critical last stage. So let us see if light crosses the last stage, what happens? Now the light is hitting the interface at an angle greater than the critical angle. Already it is 90. So what will happen? The light will come back into the same medium. And when light is coming back into the same medium, then it is reflection. And therefore this is called as total internal reflection. So students, this you can see is an actual experiment of total internal reflection. Here a beam of red light has been made incident at the interface, and you can see when it is hitting the interface at an angle greater than the critical angle, the entire light is coming back into water, and this is total internal reflection. Let us understand one very wonderful phenomena which is based on total internal reflection, students. Have you seen water on highway, that is on roads in summer season on a hot afternoon? It looks like water. This, students, is a mirage. So let's understand what is the mirage, or what is the effect of mirage. Now students, let us say these are travelers. These travelers are traveling in desert. Now when they are traveling in desert, what exactly happens? Deserts are hot. So as they are hot, the air above the desert also gets heated. When the air above gets heated, they rise up. And when this air rises up, a rarer medium is created, and above a denser medium is created. Now light from the sun is traveling in all directions. So when light from the sun is traveling in all directions, there are some light rays which will travel upwards, hit the sky, get scattered and come downwards. Now when this light rays is coming downwards, these light rays are actually traveling from denser to rarer. So students, you can see here, these light rays are traveling from denser to rarer. When they're traveling from denser to rarer, if they hit at an angle greater than the critical angle, then we know what will happen is total internal reflection. So this light from the sky undergoes total internal reflection and goes into the observer's eye. So when this observer sees in the front, he will see the reflection of the sky on the desert, which will look like water, and that is nothing but a mirage. Students, here you can see an actual picture of a mirage. So this particular area is actually looking like water, but it is not water, it is a mirage. So students, this was the understanding of mirage and total internal reflection. Thank you.